All right, this is the beginning of chapter 8, everybody. This chapter is titled Estimating the Parameter, chapter 8. Um, so, in the lessons folder, we're going to do the mystery mean, 8.1, and then the whole lesson is centered around these chapter 7 test scores. So, here's a population of the 87 chapter 7 test scores from the most recent test. So the students are in bold, the scores are right next to them, and there's 87 students that you can see here. The idea of the lesson is we want to estimate the mean of this population. I don't have time to add up all 87 scores, neither do you. So we're going to take a random sample of 5 scores. So in the notes it says we're going to guess the mystery mean, right? We're going to guess it as best we can by taking a random sample of 5 test scores. Okay, so to do that, um, you're going to get your calculator and do the random integer button. That's math probability number 5. There were 87 scores, so we'll do it like this. Just make sure your 5 numbers there are unique. We don't want repeats. Then bring up the test scores, and I need to find the matching test scores. So for example, right there, I've got student number 27. They scored 24 and a half. Oh, I should probably tell you also that this test was out of 42 points. So it might be kind of a fun little exercise to look at these scores here, look them up and down a little bit and get an idea for them. And what do you think? Take a guess. What do you think the average is for all 87? And that's what the lesson's all about. My next student was number 87. Oh, that's the very last student. They scored 30 and a half. And you're going to do the same thing. Get your own sample. Okay, so you can pause the video right now if you want to do that and stop listening to me. And I will continue and find my sample. Divided by 5. Okay, so my sample, I'm going to record my numbers. So I had a score of, my scores were 24 and a half, 30 and a half, 30, 40. Remember, it's out of 42. Oh, wait, 40.5, and 33. I added them up, divided by 5, and I got a mean of 31.7. All right, so um, that you'll have your own average. You'll have your own. The population is all 87 test scores, okay? And the parameter is the mean of all 87 scores. And we call that mu. The sample was 5 random scores, and the statistic is what you got. I got 31.7. It came from a sample, so it is X bar. Okay, you have your own number. So now mine is 31.7. Yours may be higher, it may be lower. Based on the sample, what is your estimate for the true mean of Chapter 7 test scores? In other words, if you had to pick a number right now for mu, what would it be? Well, the most logical thing to do would be to just pick your statistic right now. So I would say I'm going with 31.7, okay? That is going to be my point estimate. We are going to create an interval that I believe the true average will be within. And for me, the point estimate is 31.7. That's going to be the center. We did this in class. Every student did this, and will everyone get the same point estimate, the same number? Of course not. These are random samples. We're going to get different numbers all around the room. The highest I've seen in the years I've done this lesson is an X bar of like 34 and a half, 35. The lowest is like 23. Okay, so they're random. All right, because there's variability when you take samples, you're going to change your point estimate to an interval. In other words, I'm going to give myself a little wiggle room, a margin of error on both sides of 31.7. So we're going to add and subtract the same number to 31.7 to my point estimate. So how much would you need to add and subtract so that I'm 95% confident the interval will capture mu, the true mean chapter 7 test score? Well, 95% is the most common percentage we do. If you remember the empirical rule, 68, 95, 99.7, there's the 95. Sketch this normal curve in your notes, and we're going to go plus 1, plus 2, plus 3, right? So 68 is plus or minus 1, 95 is plus or minus 2, and 99.7 is plus or minus 3. And we are doing 95%. So I'm going to go up 2 and down 2, and I've put little vertical bars there. And this will be my 95% interval from here to here. Now, the center of the distribution, if you remember last chapter, the center is going to be what my sample tells me, 31.7. So for me, I'm going to write in that number. I want you to put your X bar right here. I'm putting mine, 31.7. Okay, right here. If I had to guess right now, that would be my guess. If you had to guess, it would be your X bar based on your sample. Then the question is, how far is it from here if I go up 1, 2 standard deviations and down 2 standard deviations? We're going to use the standard deviation formula for a sample mean. This was on your cheat sheet for the Chapter 7 test. The standard deviation of the X bars, of all the X bars all around the room, right? It's going to be the standard deviation of the population divided by the square root of n. I know sigma is 6.8 because I put all the scores in the gradebook, and I can just click on the statistics, and I can get the mean, and I can get the standard deviation. So I know this, it's 6.8. If you didn't know this, if you didn't know sigma, you could find S sub x. Just saying, you could put these numbers into list 1 on your TI-84, and you could do one sample statistics. So I might as well just do this, 24.5, 30.5, 30, 40.5. That's my 5 numbers. And then do my one variable stats. And there you go. There's my X bar, 31.7. And I would do this if I have no idea what the standard deviation for the population is. And then in this case, I would use S sub x, which you can see on my calculator screen, is 5.81. And that's what I would use. Okay. Anyway, then you divide by the square root of 5 because that's my sample size. 6.8 divided by square root of 5 gives me 3.04. I'm just going to round it off to 3. You will have the same answer as me because we are both using sigma which is for the entire population of all 87 test scores, okay? So what I just learned is the standard deviation of this sampling distribution is about 3. So it would be plus 3 to get to here, and it would be minus 3 to come down 2 standard deviations. So in other words, well, just to make it more apparent, 31.7 is the middle, add 3. So this line would be 37.7. And if I likewise went down 3, I would have 25.7. So my interval is, it might be written like this. I am 95% confident the interval from 25.7 to 37.7 captures the true mean of the 87 test scores. Okay, and you might also see this written like this, 25.7 comma 37.7. Okay, that's like interval notation. Okay, and the margin of error in this case is plus or minus 6, because I went from the center, I went up 3, so I went up 6, and then I went down 3, down 3. Okay, that's the margin of error. You might see it as MOE. Okay, we're 95% confident that the interval from 25.7 to 37.7 captures the true mean of the 87 test scores. Okay, so yours is different than mine, right? Now, why is it 95%? It's because I believe that if I took more X bars, more samples, I believe they would be centered on 31.7, but sometimes they're going to be a little bit high and sometimes they're going to be a little bit low. But if I go up 2 standard deviations and down 2 standard deviations, I'm going to capture 95% of this curve. So that's where that comes from. If I only went up 3 and down 3, and I went to here and here, that would be 1 standard deviation up and down. That would be a 68% level of confidence. So I would say I'm 68% confident that the numbers are between here and here for the true average. So you can change your interval percent to any of these. And it's more than just these 3 we'll get into later, but you can change your percent. But changing your percent, notice, is going to change how wide your interval is. I've got the green lines, which is 2 standard deviations. I could also go 3 lines. I could go here and here, and then my interval, notice, is getting wider, and my percentage is going up. So what was the actual true test average? Well, the average was, and this is mu was 30.19, okay? So that is in here, it's captured is what we like to say. It's captured in the interval, which is good. Which I was 95% confident it was going to be captured in there, and it's smack dab pretty much in the middle. And I'm guessing yours captured it, but not always. Only 95% of them are going to capture it. All right, moving on to these 2 questions. These have nothing to do with Chapter 7 test score, so you can kind of move forward. They're just letting you know different ways to have notation. They're saying a different class or a different group of kids did the same thing, and they got an interval from 81 to 89. This is like interval notation, kind of like I wrote over here. So this could be drawn up like this, okay? 81 is the bottom, 89 is the top. Draw like a number line, put a dot in the middle. The middle is the point estimate. Again, remember that's the center of the interval. When the numbers are nice and round like this, it's pretty logical that you could get that 85, but it's going to just be a plus b divided by 2. A is the low side, b is the high side. 81 plus 89 divided by 2 is 85, which is the center. If you want to know the margin of error, that's how far you go up and down from the center. You can do b minus a divided by 2. 89 minus 81 divided by 2, which is 4. So that's how that works. So again, point estimate is the number in the middle. And MOE, the margin of error, is how far we have to go up and down from the middle to get to the edges of the interval. Okay, and the margin of error is determined by your percentage, right? Like we kind of talked about earlier. If you want your margin of error to be small, you use a smaller percentage. If you want your margin of error to be big, you use a larger percentage. You might also see it written like this, 85 plus or minus 4. X bar is the average or the center, and the margin of error is 4. So again, 85 plus or minus 4. Mr. Wilcox claims that, this is his class, I guess, that the mean Chapter 7 test score was 84. Does this interval here support or deny this claim? Essentially, check this. Is the parameter in the interval? Is it captured in the interval? And yes, it is. 84 is right about there. So the interval does support it. And if this was a 95% interval, just remember 95% of the time, 84 would be in here. But there is a 5% chance that 84, you did your work correctly, but the interval you got was either shifted too low down here or it was shifted too high up here and it missed the 84 in the middle. That can happen. Here's your quick notes. This is the sentence frame that you're going to use over and over to interpret your confidence interval. Your confidence interval always is your point estimate plus or minus the margin of error. You put your percentage here and make sure you include the context. Here is, I had this higher up, but here it is in quick note form. If you want to find the point estimate and you know the beginning and the end of the interval, just add them up and divide by 2. If you want to know the margin of error, you can do b minus a divided by 2. You can also do b minus the point estimate. Like I didn't do that up here, but that would be like b minus the point estimate, minus 85. 89 minus 85 is also 4, the margin of error. And then if you want to see if your interval supports a claim, you check to see if the value, the claimed value, is contained in that interval. That's it for 8.1. See you later.